When dealing with an outdoor receptacle installation on an existing 2-wire circuit, several factors and code considerations come into play. Firstly, let's review some relevant National Electrical Code, or NEC, references. NEC Section 250.130. C addresses the grounding of receptacles. NEC Section 300.3. V covers wiring methods for branch circuits and feeders. Finally, NEC Section 406.4. D5 discusses ground fault circuit interrupter, or GFCI, protection for receptacles. Given these codes, here are some possible solutions to consider. Firstly, you could install a 3-wire circuit. This is often the most straightforward solution from a code compliance perspective, but it does involve more extensive work. This would involve running a new 3-wire underground feeder, or off cable from the electrical panel to the outdoor receptacle location. You would then connect this new cable to a GFCI receptacle, ensuring that the ground terminal of the receptacle is properly connected to the ground wire in the new cable. Secondly, you could consider using a GFCI breaker. Instead of replacing the wiring, you could install a GFCI circuit breaker in the electrical panel for the circuit that feeds the outdoor receptacle. This GFCI breaker provides equivalent protection to a GFCI receptacle, but it doesn't require a ground wire at the receptacle location. It's important to note that while this approach provides enhanced safety, it may not be explicitly permitted by the NEC in all jurisdictions, and some electrical inspectors may have reservations about it. Check with your local inspector. Thirdly, hardwiring the transformer is an option. This approach eliminates the need for a receptacle altogether. Firstly, disconnect the existing UF cable from the current receptacle. Secondly, install a suitable junction box with a weatherproof cover plate at the location. Thirdly, hardwire the transformer for the low voltage outdoor lights directly to the UF cable inside this junction box. If you are using a cable to connect the transformer to the junction box, ensure it's a non-metallic sheathed cable suitable for the environment. Finally, clearly label the junction box as no ground outdoor lighting transformer. Fourthly, obtaining a variance is another possible route. This involves directly engaging with your local building department. Firstly, contact the building department and request a variance from the standard 3-wire requirement for outdoor receptacles. Secondly, explain the unique circumstances of your situation, such as the fact that you're working with an older home that only has 2-wire UF cable available. Be prepared to clearly articulate the steps you've taken to ensure safety, such as the implementation of GFCI protection. Now, let's consider some additional factors. Remember that any outdoor receptacle you install must be specifically listed for use in wet locations to ensure safety and prevent corrosion. The transformer itself must be rated for outdoor use, meaning it's designed to withstand the elements and is protected by an overcurrent device like a fuse or circuit breaker. When burying UF cable, it's crucial to adhere to the required burial depth specified by the NEC and local codes. This depth is typically around 18 inches to protect the cable from physical damage. During installation, exercise extreme caution to prevent puncturing or damaging the UF cable, as this could create a safety hazard. Finally, remember that electrical codes can vary depending on your location, so consulting with a qualified electrician is always a good idea to ensure compliance and safety. When dealing with older wiring systems, it's not uncommon to encounter situations where a grounding wire is absent. In these scenarios, careful consideration must be given to safety and code compliance. While simply replacing a 2-prong receptacle with a 3-prong receptacle without providing a proper ground connection is not a safe or code-compliant practice, there are alternative methods that can enhance safety when a grounding wire is not available. One acceptable method is to install a ground fault circuit interrupter, or GFCI, receptacle. A GFCI is a safety device that monitors the current flowing in a circuit and quickly interrupts the power if it detects a difference between the outgoing and returning current, which could indicate a ground fault. When used in a 2-wire circuit without a grounding conductor, a GFCI receptacle provides a level of protection against electrical shock. The GFCI receptacle is designed to trip and to energize the circuit if a ground fault occurs, reducing the risk of electrical injury. It's important to note that a GFCI receptacle does not create a ground connection. It simply provides a faster and more sensitive response to ground faults than a standard circuit breaker. When installing a GFCI receptacle in a 2-wire circuit, it should be labeled with the sticker "No Equipment Ground." This label indicates that the receptacle is not connected to a grounding wire. While a GFCI receptacle can improve safety in a 2-wire circuit, it's not a substitute for a properly installed grounding system. If possible, the best solution is to run a new 3-wire circuit with a grounding conductor. This provides the highest level of safety and is the preferred method for new installations. In situations where running a new 3-wire circuit is not feasible, using a GFCI receptacle is a reasonable alternative. However, it's important to ensure that the GFCI receptacle is properly installed and labeled. Additionally, it's crucial to educate users about the limitations of a GFCI receptacle in a 2-wire circuit. While it provides protection against ground faults, it does not provide the same level of protection as a properly grounded circuit. When working with electrical systems, safety should always be the top priority. If you're not comfortable working with electricity, it's best to hire a qualified electrician. An electrician can assess the situation, recommend the best solution, and ensure that the work is done safely and in accordance with the National Electric Code or NEC. When adding outdoor electrical components such as receptacles and transformers, it's essential to consider the specific requirements for outdoor installations. Outdoor electrical components must be rated for use in wet locations and be protected from the elements. Receptacles should be weatherproof and have covers that protect them from rain and moisture. Transformers should be designed for outdoor use and be properly enclosed to prevent water from entering. When installing outdoor wiring, it's important to use the correct type of cable and bury it at the proper depth. Underground feeder or off cable is commonly used for outdoor wiring because it's designed to withstand moisture and physical damage. The NEC specifies the minimum burial depth for UF cable, which is typically 18 inches. It's also important to protect the cable from physical damage by running it through conduit in areas where it could be exposed to vehicles or other hazards. When connecting outdoor electrical components to an existing circuit, it's important to ensure that the circuit is properly sized and protected by a circuit breaker or fuse. The circuit should be able to handle the additional load of the outdoor components without overloading. It's also important to check the ampacity of the wiring to ensure that it's adequate for the load. If the wiring is too small, it could overheat and cause a fire. When working with electrical systems, it's always best to err on the side of caution. If you're not sure about something, consult with a qualified electrician. An electrician can help you assess the situation, recommend the best solution, and ensure that the work is done safely and in accordance with the NEC. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it, and use insulated tools. Wear safety glasses and gloves to protect your eyes and hands. And never work on electrical systems when you're wet or standing in water. By following these safety precautions, you can minimize the risk of electrical shock and ensure that the work is done safely. When dealing with electrical inspections, it's important to understand the role of the electrical inspector and the purpose of electrical inspections. Electrical inspectors are responsible for ensuring that electrical installations are safe and comply with the NEC. They inspect electrical work to identify any potential hazards and to ensure that the installation meets the minimum safety standards. Electrical inspections are typically required for new construction, renovations, and additions to existing electrical systems. The inspection process involves a thorough examination of the electrical work to verify that it's done correctly and safely. The inspector will check the wiring, grounding, bonding, overcurrent protection, and other aspects of the installation to ensure that they meet the requirements of the NEC. If the inspector finds any violations, they will issue a correction notice that identifies the problems and requires them to be fixed. Once the corrections have been made, the inspector will re-inspect the work to verify that it's now in compliance with the NEC. It's important to cooperate with the electrical inspector and to address any concerns they may have. The inspector is there to help ensure that the electrical installation is safe and that it meets the minimum safety standards. If you disagree with the inspector's findings, you have the right to appeal their decision. However, it's important to do so in a respectful and professional manner. When working with electrical systems, it's always best to follow the NEC and to consult with a qualified electrician if you have any questions. The NEC is a comprehensive set of safety standards that are designed to protect people and property from electrical hazards. By following the NEC, you can help ensure that the electrical installation is safe and that it meets the minimum safety standards. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it, and use insulated tools. Wear safety glasses and gloves to protect your eyes and hands. And never work on electrical systems when you're wet or standing in water. By following these safety precautions, you can minimize the risk of electrical shock and ensure that the work is done safely. When dealing with older homes and electrical systems, it's important to be aware of the potential challenges and safety considerations. Older homes may have wiring systems that are outdated or that don't meet current safety standards. For example, they may have knob and tube wiring, which is an older type of wiring that is no longer considered safe. They may also have two-wire systems without grounding conductors, which can increase the risk of electrical shock. When working on electrical systems in older homes, it's important to have them inspected by a qualified electrician. An electrician can assess the condition of the wiring and identify any potential hazards. They can also recommend upgrades or repairs that will bring the electrical system up to current safety standards. If you're planning to renovate or remodel an older home, it's important to factor in the cost of electrical upgrades. The electrical system may need to be completely replaced to meet current safety standards. This can be a significant expense, but it's important to do it right to protect yourself and your family from electrical hazards. When working with electrical systems in older homes, it's also important to be aware of the potential for asbestos. Asbestos was commonly used in older homes as insulation and fireproofing material. If you disturb asbestos-containing materials, it can release fibers into the air that can be harmful to your health. If you suspect that there may be asbestos in your home, it's important to have it tested by a qualified professional. If asbestos is present, it should be removed or encapsulated by a trained asbestos abatement contractor. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it, and use insulated tools. Wear safety glasses and gloves to protect your eyes and hands. And never work on electrical systems when you're wet or standing in water. By following these safety precautions, you can minimize the risk of electrical shock and ensure that the work is done safely. When dealing with underground feeder or UF cable, it's important to understand its proper use and installation requirements. Underground feeder cable is a type of electrical cable that is designed for direct burial in the ground. It's typically used to supply power to outdoor lighting, receptacles, and other electrical equipment. UF cable is constructed with a tough outer jacket that protects the conductors from moisture, chemicals, and physical damage. It's also resistant to sunlight and temperature extremes. When installing UF cable, it's important to follow the NEC and local codes. The cable must be buried at the proper depth, which is typically 18 inches. It should also be protected from physical damage by running it through conduit in areas where it could be exposed to vehicles or other hazards. When connecting UF cable to electrical equipment, it's important to use the correct type of connectors. The connectors should be rated for use with UF cable and should be properly installed to prevent moisture from entering the connection. It's also important to ground the UF cable properly to prevent electrical shock. The grounding conductor should be connected to a grounding electrode, such as a ground rod or a metal water pipe. When working with UF cable, it's important to be aware of the potential for damage. The cable can be damaged by digging, driving, or other activities. If the cable is damaged, it can create a safety hazard and should be repaired or replaced. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it and use insulated tools. Wear safety glasses and gloves to protect your eyes and hands. And never work on electrical systems when you're wet or standing in water. By following these safety precautions, you can minimize the risk of electrical shock and ensure that the work is done safely. The GFCI, or ground fault circuit interrupter, is a crucial safety device designed to protect individuals from electrical shock. It works by monitoring the balance of current flowing between the hot and neutral conductors in a circuit. If a difference in current is detected, even as small as 5 milliamps, it indicates that some of the current is leaking to ground, potentially through a person. The GFCI quickly trips, interrupting the circuit and stopping the flow of electricity, thus preventing a severe or fatal electrical shock. GFCIs are particularly important in areas where there is a high risk of contact with water, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code, or NEC, mandates GFCI protection in these areas to ensure safety. There are two main types of GFCIs: GFCI receptacles and GFCI circuit breakers. GFCI receptacles are installed in place of standard electrical outlets and provide GFCI protection only at that specific location. GFCI circuit breakers, on the other hand, are installed in the electrical panel and provide GFCI protection for the entire circuit. When testing a GFCI, you can use the test and reset buttons located on the device. Pressing the test button simulates a ground fault, causing the GFCI to trip and cut off the power. To restore power, simply press the reset button. It's recommended to test GFCIs monthly to ensure they are functioning correctly. If a GFCI fails to trip when tested, it should be replaced immediately. GFCIs play a vital role in preventing electrical shocks and saving lives. It's important to understand how they work and to ensure they are properly installed and maintained in your home or business. When dealing with electrical safety, it's crucial to have a comprehensive understanding of grounding and bonding. Grounding refers to connecting electrical equipment and systems to the earth. This provides a low resistance path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit in the event of a fault. Bonding, on the other hand, involves connecting all metal parts of an electrical system together to create an electrically continuous path. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electrical shock. Grounding and bonding are essential for electrical safety because they help to prevent electrical shocks, reduce the risk of fire, and protect sensitive electronic equipment from damage. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure that electrical systems are installed and maintained safely. When grounding and bonding electrical systems, it's important to use the correct materials and methods. The grounding conductor should be sized according to the NEC requirements and should be properly connected to a grounding electrode, such as a ground rod or a metal water pipe. The bonding conductor should also be sized according to the NEC requirements and should be securely connected to all metal parts of the electrical system. It's also important to inspect grounding and bonding systems regularly to ensure they are in good condition. Any damaged or corroded grounding or bonding conductors should be replaced immediately. Grounding and bonding are fundamental aspects of electrical safety. By understanding and implementing proper grounding and bonding techniques, you can significantly reduce the risk of electrical hazards. Always consult with a qualified electrician for any electrical work to ensure it's done safely and in accordance with the National Electrical Code or NEC.